Hey guys, today's Thursday, September 17th, and our topic for today is going to be recipes. Okay, I want you to go ahead, pause the video at this time, and write down your learning targets. They are numerous today. We're going to hit on 3 different things when we go through our task or our activity. I can explain the meaning of equivalent ratios using a recipe as an example. I can use a diagram to represent a recipe, a double batch, and a triple batch of a recipe, and I know what it means to double or triple a recipe. Okay, so I'm going to give you a color copy. Oops. I'm going to give you a color copy of this task. Okay, and it says this flower is made up of yellow hexagons, red trapezoids, and green triangles. Okay, write sentences to describe the ratios of the shapes that make up these patterns. Well, how many red hexagons are there? I'm sorry, yellow hexagons. How many yellow hexagons? 6. And how many triangles? I see 1, 2, 3, 4, 5, 6, 7, 8, 9. So my ratio of hexagons to triangles is 6 to 9. Can I simplify that and write it as something else? Yes, I could write it as 2 to 3. Okay? How many hexagons, talking about the yellow again, for each trapezoid? Well, there are 6 hexagons, 2 trapezoids. So 6 to 2 can also be restated as 3 to 1. Ratio of trapezoids to triangles. How many trapezoids? 2. How many triangles? 9. We already talked about that one. So the ratio of hexagons to trapezoids to triangles is going to be 6 to 2 to 9. Now, how many of each shape would be in 2 copies of this flower pattern? If I had this flower pattern duplicated, let's take the easy part first. Let's take the red trapezoids. If I started out with 2 and I have another shape over here, how many is that going to give me? Of course, it's going to give me 4. Okay? Now, let's talk about the hexagons. How many hexagons in this shape? Well, there are 6. So if I had another 6 over here, that would be a total of 12. And then the triangles, how many triangles are there? There are 9. So I would double the 9, and that would give me 18. Okay? All right. So we just talked about this. So let's talk about batches of cookies. Okay? You're planning to make cookies using your favorite recipe, and you're going to double the recipe. What does it mean to double? Well, double means times what? Double means, of course, times 2. So there are a few things we need to realize. If we double a recipe, do you just need to double one ingredient, or do you need to double all of them? And the answer is, of course, we need to double all of them. If we double a recipe and our recipe makes 12 cookies, how many cookies would 2 recipes make? Well, what's 12 times 2? 24. Okay? So if I made a single recipe with 12 cookies, then I made a double recipe with 24 cookies, should I be able to tell the difference between the 12 cookie batch and the 24 cookie batch? No, they should taste the same. So, let's talk about this. A recipe for one batch of cookies calls for 5 cups of flour and 2 teaspoons of vanilla. Okay? So, task number 1. Draw a diagram that shows the amount of flour and vanilla. So flour, and I'm just going to draw 5 boxes with an F. And how many vanillas? I need 2 vanillas. Okay, there's my diagram. How about number 2? How many batches can you make with 15 cups of flour and 6 teaspoons of vanilla? Well, doesn't this make 1 batch? So if I doubled this, that would give me 10 cups of flour, right? And if I add another 5, that would give me 15. So how many batches? That's going to be 3 batches. Okay? How much flour and vanilla would you need for 5 batches? Well, how much flour and vanilla would you need for 5 batches? Well, 1 batch is 5 flours. 5 batches would be 5 times 5, right? So that would be 25. And wouldn't this other one be 5 times 2? So 25 flour and 10 vanilla. Okay. Number 4, whether the ratio of cups of flour to teaspoons of vanilla is 5 to 2 or 10 to 4 or 15 to 6, the recipes would make cookies that taste the same. We call these equivalent ratios. Okay, same thing. As a fraction, 5 over 2, 10 over 4, and 15 over 6. Now remember when we were doing those fluency facts earlier, and I said the numerator is increasing by 1, the denominator was increasing by 2. This time, how much is the numerator increasing by? Well, it's plus 5 each time. And the denominator is plus 2 each time. So I could extend this pattern on out if I needed to. Okay? All right, so find another ratio of cups to flour to teaspoons of vanilla that is equivalent. Okay, so do we want to just go to the next logical one? This is going to be 20, and this is going to be 8. So this is 1 batch. This is going to be 2 batches. This is going to be 3 batches. And this one is going to be 4 batches. Okay? How many batches? We're making 4 batches with that new recipe. Okay? Now, here are the responses, and this is what I just did. Okay? 5 to 2. A double batch, just doubled it. Right? Okay, 3 batches. And this is exactly what we just did. All right, so to double a recipe, you need to double the amount of each ingredient. To scale a recipe, generally, you need to multiply each ingredient by the same number. Scaling a recipe results in a substance that tastes the same as the original, and a ratio that represents a recipe is equivalent to a ratio that represents multiple batches of the same recipe. All right, so here's your task. Usually when Alina makes bird food, she mixes 9 cups of seed with 6 tablespoons of maple syrup. However, today she is short on ingredients. Think of a recipe that will yield a smaller batch of bird food but still taste the same. Explain or show your reasoning. And I said drop your answer in the chat. Well, if you're watching this on YouTube, we don't have the chat, so I'm going to put this on my Canvas page so you can go back to my Canvas page and submit your answers there. Okay? All right, boys and girls, see you tomorrow.